This conference will now be recorded.
Good afternoon, all. I'll be presenting a demo lecture on DFT. So, DFT basically stands for Design for Testability. So, what basically happens in DFT is, in DFT, we will be adding some extra logic into our design. We will be adding some extra logic into our design. In the software stages, we will be adding some extra logic, and we will be adding the logic in such a way, we will be designing the logic in such a way that if there are some manufacturing defects, our logic will be able to identify those manufacturing defects. So DFT means it is to insert extra logic into the design during the software stage itself, so that our design, it will be in such a way that our design will be able to detect the manufacturing defects in the chip. So the role of DFT engineer is to adding some extra designs, extra logic into the design, so that our IC, to make sure that good testing is done for our IC, so that if any manufacturing defect occurs, our logic will be able to detect it. So that's why we will make sure that good testing is done for the IC. And DFT engineers, we do not check the functionality of the chip. We just check the quality of the chip. Functionality means how the chip works, the working of the chip. We will not be checking the working of the chip. We will be checking the quality of the chip, whether the chip is free of bugs or not. So I'll just discuss a few prerequisites of this course. So you need to have basic of digital electronics. So and basics of analog electronics is also required. So you need to have a basic of HDL language, anyone. So Verilog or system Verilog you need to have. So we will be like not in depth, like just the basics of Verilog or system Verilog or VHDL. Any one HDL is required. So we will mostly be focusing on Verilog. And then you have to have an understanding of the VLSI design flow. So that is the ASIC design flow, which I'll be discussing in the later slides. Next, we need to have a basic idea of EDA tools. So yeah, EDA tools will be discussed in our course. So EDA, we will be dealing with our course, complete course with EDA tools only. So EDA tool stands for Electronic Design Automation. So why EDA tool is required? Because we will be like yeah, like what EDA tools means, these EDA tools, they will be performing tasks on its own, but we have to give instruction to the EDA tools so that they will be performing the task. So we will be dealing with the EDA tools throughout our course in order to accomplish our task. So these tools, they will be inserting the logic on their own, but we have to give instruction to the tool what the logic has to be inserted. And basic knowledge of C is required. So that is because you need to understand any one of the scripting languages, that is Perl, Shell or Tcl. So why the scripting languages is required is because EDA tools, they will be performing the tasks on their own, and we have to give instruction to the EDA tool. So we will be giving instruction to the EDA tool with the help of these languages. Okay. So we will be giving instruction to the EDA tool with the help of Tcl languages. For our EDA tools, we will be using Tcl language. So Perl and Shell are also similar to it. So Tcl language, it is similar to your the scripting languages structure will be similar to your C language. Okay, so that's why if you know your C language, then you will be able to easily understand the structure of the scripting languages. So these are the prerequisites of this course. And next is who can attend this course. So if you're a final year student and if you want to get a job in DFT domain, you can attend this course. And if you're a new college graduate with relevant branches of engineering like ECE, E&I or EEE, you can attend this course. And if you are some lecturers or professors who want to change to real-time industry, they can also attend this course. And also working professionals in VLSI domain, like if you are from PD team or design team, if you want to change your domain to DFT team, then you can attend it. And also other working professionals like software engineers or other people who want to change their domain can take up this course. So now we will see what is VLSI. So VLSI, it stands for very large scale integration. Very large scale integration. This is the full form of VLSI. So a very large scale integration means we can actually tell it as millions of switches in a small area. So implementation of millions of switches in a small area. Small area is nothing but our IC, integrated chip. Okay, integrated circuit, that is the IC. And millions of switches is nothing but our MOSFET logic, CMOS, that is a combination of NMOS and PMOS. So our MOSFET logic. Okay, so implementation of millions of MOSFET in a small area, that is in the IC, that is what is called as VLSI. So we will see the motives of VLSI. So motive means if someone wants to design a chip, then they will be having some primary conditions or primary targets which has to be achieved in order for their chip to be good. So these conditions are: first is high performance. High performance means it is nothing but the timing response of the chip, how fast our chip responds. So that depends basically on the clock. Next is low power. So if power increases, if we have a high power, then our chip will get damaged. So we have to make sure that our chip consumes low power. And then low area. If our chip consumes a large area, if the chip size is large, then obviously our board size will increase. If our board size increases, then our product size will increase. So in order to avoid that, we can have a low area. Okay, we have to achieve the low area, that is the chip size should be reduced. So these are the primary motives of VLSI, that is if someone is designing a chip, they should achieve these primary targets. Only then we can say that our chip is good. So now I will tell you the ASIC flow. Okay, so ASIC flow, what basically this ASIC flow means is it actually gives you the steps which we have to follow for designing a chip in the software stage. So what are all the steps the chip has to go through in order for it to get designed. Okay, not only in the software stage, even the hardware stage process will also be included in the ASIC flow. So what are all the steps the chip has to follow like from the beginning till the end? What are all the steps we have to follow in order to design a chip? That is what will be given in this ASIC flow. So the full form of ASIC flow is application specific integrated circuit. So application specific. So application specific means it is like specific to a particular application. So for example, if you are designing a chip for medical industry, you can use the chip only for medical industry alone. You cannot use the chip for automobile industry. Okay, so that is what is called as application specific. So the chip will be designed specific to a particular application which you are doing. Particular application in the sense particular industry, for which industry you are designing the chip. Okay, so this is what it actually gives us, the steps which we have to follow for designing a chip. So now I'll tell you one by one the steps which has to follow in order to design our chip. So the first step is design specification. So design specification means based on the applications, like based on for which industry we are designing the chip, whether it is for aero industry, auto industry or medical industry, etc. So for which industry we are actually designing the chip, based on that we will be having some specifications. So these specifications, they will be decided by very experienced people, like 20 to 25 years of experience they'll be having. So they are called as architects. Okay, so these architects, they will be deciding the specification of the chip based on these specification will be decided based on for which industry we are actually designing the chip. Okay, so next comes our design team. So design team, they will be writing the design code that will be in either Verilog or VHDL form. Okay, so based on the specification given by the specification team, the design team will be writing a Verilog code for the chip. The design of the They will be designing the chip and it will be in the form of Verilog code. And these design team engineers, they will also be called as RTL engineers. RTL actually stands for Register Transfer Level. Okay, so if you just see the it will be in the format of the data being transferred from one register to other register. So data is transferred between registers. That is why it is called as register transfer level, and these engineers are called as register transfer level engineers, RTL engineers. And basically the RTL engineers, they will be writing the Verilog code for the chip based on the specification given by the specification team. Verilog code means it will be in the format of behavioral Verilog code or data flow level Verilog code. Behavioral Verilog code means you'll be having all those assign statements, if loop, case statements, all those things you'll be having. And data flow level means you'll be, sorry, behavioral means you'll be having like, yeah, always block, not assign statement, always block, and then the loops or if conditions, all those things if you are having, that is the behavioral form of Verilog. And data flow level form of Verilog means you'll be having continuous assignment statement. So the Verilog code will be written either in behavioral format or data flow level format. So this is what is done by the design team. So once the design team has written the code for the chip, whether the code is correct, whether the code is working based on the required functionality or not, so that is done by the verification team. The verification team, they will check whether the code, whichever code is written by the design team, whether it is working as per the functionality, original intended function or not. So that those things, those checking will be done by the verification team. So they have some methodologies. Verification team, they have their own methodologies, so based on which they will check whether the code whichever is written by the design team, whether it is functioning properly or not, and whether it is still based on the specifications or not. And till this point, the code whichever is there, it is either in behavioral format or in data flow level format. So say for example, I'll just write, if we are actually want to writing a flip flop means it will be something like this. So always at pause edge clock, so q is equal to d, something like this. It will be in this format till this point. So if this code, if it is given to a layout engineer, the layout engineer, this is a very simple code, that's why we are able to understand what it is. But if the code is complex, then the layout engineer will not understand what they have to place. So in order for that, we will be having another stage called as synthesis stage. So in synthesis stage, the behavioral or data flow level code written by the RTL engineer, it will be converted into structural form. That is in gate level form, it will be converted. It will be technology node specific, like 30 nanometer or 24 nanometer, like the technology node specific it will be there. Okay. So this conversion of the RTL code, that is behavioral and data flow level modeling code, into gate level code is done by the synthesis team. Okay. And Next, we have our DFT team, design for testing team. So as I told in the previous slides, so DFT team, we will be inserting some extra logic into the design, and that is done during the software stage itself. And we would have designed a logic in such a way that if suppose we get a manufacturing defect, after manufacturing if there are some defects, our logic will be able to tell what has actually caused the defect. So in order to detect the manufacturing defects, we are going for DFT. And you'll actually get a question like, can functional verification engineer also detect the manufacturing defects? The answer is yes. Even functional verification engineer can also detect the defects. But why we are specifically having a team called as DFT team? The only disadvantages, like the time taken for functional verification engineer, it will be more when compared to design for testing engineer, that is DFT engineer. So say for example, if a verification engineer, if he takes 2 days to test a chip, then DFT engineers will test the same chip in less than 2 seconds. And why the testing, the why this time for testing plays a major role is, so because after manufacturing we will actually be testing a chip in a tester. Okay, so we'll be having a tester, and after manufacturing we will be placing the chip onto our tester. Okay, and we will be applying the not DFT engineers, the tester engineer will be doing it. Okay, so input pattern will be applied and the output responses we will be getting it. So this is what will be done after manufacturing of the chip. So this tester is actually very costly. So like all the companies cannot afford this tester. So what will happen is, one company will be having a tester. So that company, say for example company A is owning a tester, he will be like, that company A will be renting the tester to other small companies. If the companies cannot afford the tester, they will be taking rent for the tester. Even that rent is also very costly, it depends on dollars per second. So if we take 2 days to test a chip, then the cost of testing will be very high. So instead of that, if our chip gets tested in less than 2 seconds, then it is a profit for us. So that's why, in order to reduce the time of testing, and in turn, in order to reduce the cost which we are which in order to reduce the cost for testing, we are having this DFT engineers. And how the DFT engineers are able to test the chip in less time when compared to functional verification engineer is because the inputs whichever we are giving to the tester, those inputs we will be able to give a optimized input. So DFT engineers will be able to give a optimized set of input values that has to be applied onto the chip in order to test the chip. Okay, so that is why we are able to reduce the testing time, and in turn we will be able to reduce the cost of testing. After the DFT team, we will be having the physical design team. So physical design team, they are responsible for the layout of the digital circuits. And next we have the sign off team. So sign off team, they are basically they take care of STA, starting timing analysis, whether the timing is met properly or not. And then they take care of physical verification, that is they verify whether the layout done by the physical design team, whether it is correct or not, that is verified by the sign off team, and the process is called as physical verification. And then they do logical equivalence check. Logical equivalence check means they check whether our chip has not deviated from the design specifications or not. Okay, the design specification which was done at the first stage, whether our chip has deviated from it or not, that is done by the sign off team in the step called as logical equivalence. And after this we have our tape out. So tape out is, we are delivering the database to the manufacturing unit. So till this time it will be a software stage only. Okay, where everything is done in the software stage only. So only in the tape out phase So tape out is not a team actually, it is just a phase. So in tape out phase, we will be delivering the database to the manufacturing unit. And after it is manufactured, we will be doing packaging and testing. So this testing only I told here, after manufacturing the testing, they will be placing it onto a tester and they will be applying the input values and they will be getting the output responses, and this output response will be compared with the golden response. Golden response means the expected value. Okay, so that is what is called as testing. So we will see what is testing in our next slide. So testing means it is a process of determining whether a device is good or not. That is whether the device, whether it has any bugs or not. So testing basically includes test pattern generation, application, and then output evaluation. So the test pattern generation, this test pattern will be generated by our DFT. And application means those test patterns will be applied onto the chip. And output evaluation, the output values will be compared with the expected values. So here if you see the test pattern, so this test pattern will include the input what the input has to be applied as well as the expected output. So expected output is nothing but the golden response, what must be the expected output. So this test pattern, uh, uh, from this test pattern, the input stimulus is nothing but the input patterns are applied to the uh, device under test. DUT is nothing but device under test. So inside the tester we will be placing our chip. So if this is the tester, our chip is nothing but the device under test. So the input values will be applied onto our chip and we will be getting our output response. So the output response, it will again be compared with the test pattern because the test pattern also has the expected output. So expected output, this is at the output, this output, it will actually be called as the simulated output. So the simulated output will be compared with the expected output. If simulated output is not the same as expected output, then that means there are some defects in our chip. And DFT engineers will be identifying what has actually caused the defect. So if a particular chip fails on a tester, which means like if the simulated response is not the same as expected response, the testing engineers, they cannot analyze it. So DFT engineers will be analyzing why the chip has failed and how we are able to analyze it. The logic whichever we have added during the software stage, so that with the help of that logic, our tool knows what has actually caused the failure. So now we'll see like we have told like DFT engineers will be able to detect the manufacturing defects in the chip. So what are the possible? I'll tell you a few manufacturing defects, which can like few defects which can happen during manufacturing. So one is metal scratches. So the wires, right? It will be created using metal layers. Okay, the wires whichever we are using, whichever are there inside the chip, that will be created using metal layers. So if there are like any scratches in those metal layers, so that can be a manufacturing defect. And next is missing wires. So as I told, wires whichever is used in the chip, so that will be made up of various metal layers. So there will be some connection between the two layers. Okay, so that connection is only called as wires. If there are some missing wires is nothing but the wire nodes, the connection between the two layers. So if that is missing, then that can also be a part of manufacturing defect. And next is poly cracks. Poly is nothing but it is a layer which is used for MOSFET terminals. So if there are any cracks in that layers, that is called as poly cracks. And same way poly bridges. So connection between two terminals of MOSFET. There should not be any connection between two terminals, that is the source, drain and gate. So there should not be any connection between the two terminals. If suppose there are any connections between the two layers of the MOSFET, then we call that as a poly bridges. Now I will discuss a few points about the course outline. So first we will be having our DFT architecture. So DFT architecture is, we will just basically see an overview of DFT. We'll just see that is how we control the functional circuit with our DFT circuit. Okay, so that is what the overview of DFT, we will be seeing it in the DFT architecture. Okay, so like we will also be having various specification which we have to make as a DFT engineer for our DFT circuit. So how to decide those specification and how to control our functional circuit with the help of our logic, that is DFT circuit, how to do it. So the overview will be seen in this DFT architecture. Next, we'll be having the scan insertion. So scan insertion, it is basically to test the combo logic as well as the sequential logic. And next we have the compression. So as I told in the previous slide, DFT team, it is to, they are actually to reduce the test time for DFT. Test time for the chip. Okay, testing, to reduce the testing time of the chip, we go for DFT. So we go for compression in order to furthermore reduce the test time which is required for DFT. So I'll just give you an example. So say for example, without DFT, if we are able to test a chip in X unit of time, then with the DFT, we will be able to test the chip, like testing time, it will be reduced by, say for example, 10,000 times. Then with the compression, this is with the DFT. Now with the DFT, along with that, if we go for compression, then we will be able to reduce the testing time by 1 lakh seconds. Okay, like this will be like X by 1 lakh. Okay, furthermore, we are actually able to reduce the testing time for DFT. So without DFT, if we are able to test the chip in X unit of time, then with the DFT, we'll be able to check that, we'll be able to test the chip in X by 10,000 unit of time. And along with DFT, if we go for compression, then we will be able to test the chip in X by 1 lakh unit of time. So we are reducing the test time which is required. And next is on chip clock controller, that is nothing but OCC. So this we will be this is also a topic which we'll be discussing in detail in our course. And next is automatic test pattern generation. So as I told, DFT team will be generating optimized patterns which has to be which will be given to the tester team, right? So this test pattern generation, so that is what is coming under this ATPG. And next we have simulation. So simulation is to validate the patterns which were generated during ATPG. And next is MBIST. MBIST is memory built-in self-test. So memory, it is actually a analog logic. Okay, so you will not be having any flops in the memory. So we cannot actually test our chip, test our memory using scan insertion and ATPG. So we have to have a separate mechanism to test our memory because we don't have flops in it. Only if we have flops in our design, we'll be able to check using scan insertion. If we don't have flops, say for example memories, it does not contain any flops. It is an analog logic. So we have to have a separate mechanism to test our chip, test our memory. So that mechanism is only called as built-in memory built-in self-test. Next is JTAG. JTAG is Joint Test Action or Access Group. So JTAG, it is actually a standard IEEE standard protocol, and it is basically used by design team to reduce the number of pins which is required for DFT. So we will be discussing it in detail in our course. And next is boundary scan. So boundary scan is that So boundary scan is nothing but, say for example, we are having two chips. I'll name this as chip 1 and chip 2. So this chip 1 will be tested separately and this chip 2 will also be tested separately. But if there are some interconnects between the two chips, in order to test that, then we will be going for a process called as boundary scan. Next, I'll tell you the flow of DFT. So first is insertion. Insertion means adding the extra logic. So that is what is scan insertion and compression. Next is pattern generation. That is input pattern plus the expected output. So that pattern generation is done during the ATPG stage. And finally, validation of the patterns which are generated during ATPG stage will be done in our simulation stage. So this is the flow of DFT. So now I'll tell you what are all the companies you'll be getting offer in. So one is product based companies. So product based companies, they will be like building their own product and selling it into selling it in the market. So say for example Qualcomm, Intel, Microchip, all these companies, they will be designing their own chip and they will be selling it to the to the market, okay, to their vendors. In the market, okay. And the other type of company is service based companies. So service based companies, they will be building the product, they will be building the chip for the product based companies, for their clients. So say for example Capgemini is one of the service based company. So if Capgemini if just for example I'm telling, if Microchip is the client of Capgemini, then Capgemini will be designing the chip for Microchip, okay. So that is the difference between the product based companies and service based companies. Product based companies, they will be designing their own chip and they will be selling it into the market. Service based companies means they will be designing the chip, or a part of the chip they will be designing for their clients. Their clients are nothing but the product based companies. And next we will see what are all the tools which are required for DFT. So these are the various tools which is available in the market for DFT. So that is for MBIS, synthesis, scan, insertion, compression, ATPG, and then for simulation. So these are all the various companies, Synopsys, Cadence, and Mentor Graphics. They will be providing these tools. So in our institute, we will be making use of Mentor Graphics tools. Okay. So for MBIS, we'll be using Tessent MBIS. For synthesis alone, we will be using design compiler. Only for synthesis, we will be making use of design compiler, which is the Synopsys tool. For scan insertion, we'll be using Tessent DFT Advisor. For scan compression, we are using Tessent Compressor. For ATPG, we are using FastScan. And for simulation, we are using Questa Simulator. So except synthesis, all the tools we are using the Mentor Graphics tool. Only for synthesis, we are using the Synopsys tool, that is DC compiler. So now I'll tell you what are all the labs which will be discussed. So one is MBIS labs, and then we'll be having test cases for IJTAG and scan insertion. Both, there are two approaches. One is top down and hierarchical approach, bottom up approach. So for both these types of scan insertion, we are having test cases, and then EDT and OCC insertion, ATPG pattern generation, ATPG and MBIS simulation. Okay, so these are all the labs which we are having. And how the institute provides the placement support. So they are having tie-up with various VLSI companies, and uh, if you are enrolled for this course, you will be given various assignments, tests, and also mock interviews, and also rating will be given on how you interact in the class. So based on those ratings, or based on those performance, based on that, each student's performance will be categorized, and based on that, you will be getting the placement support. Okay. But it doesn't mean that if your performance, if your rating is low, it doesn't mean that we'll not be providing placement support. We will be giving you extra support so that you will be able to get placed in a company. Okay, in order to just just keep in track of your um, uh, like um, your performance, we'll be having all these assignments and tests, and also performance rating which will be given during the class. So if your performance is low, it doesn't mean that we will not be providing you placement support. We will be giving you extra support so that you will gain the necessary skills in order to get placed. And then mock interviews will also be conducted. Then previous year questions will also be discussed. Previous interview questions, like some preparation sessions will be there where we'll be discussing you the previous interview questions. And yeah, this is the end. So if you have any doubts, you can ask. I'm not audible. Okay, was I audible? I did not check the chat box. Am I audible?
Yes.
Okay. So, was I audible throughout the session, or in between my voice was breaking?
No, nothing like that. It was audible throughout the session.
Okay. So, do you have any doubts? If there are no doubts, shall we wind up the session? Yes, this is just a demo lecture. So, this is all for this session. So, if you have any doubts, you can ask. The assignments, yeah, you will be able to do it on your own. And even if you are not able to do it, we will be providing support sessions. And those assignments will be only for your, like your whatever has been discussed in your class. So based on that only, we will be giving you the assignments. Nothing will be new. So whatever is discussed in the class and whatever is discussed in the labs, based on that, you will be given the assignments. So you will be able to do the assignments on your own. And even if you are not able to do it, we will be providing you support. 4 years career gap. Uh, I'm not sure this one whether there will be any problem in the placement. I'll just contact management side sir to take over this question. I'll just call sir once to join the session. The placement starting, all those things, I'll just call management side sir, and I will ask sir to address those questions. So just a minute. Sir said he will join in 2 minutes, so you can ask these questions to sir. Uh, yeah, all those questions sir will be addressing. Sir will be joining the session in another 2 minutes. So after he joins, he will clarify these doubts. No, we did. You do not need to purchase any textbook. So we will be giving you all the necessary course materials. Yes, the recording of the sessions will be available to you in your InSkill portal. So every day's class will be recorded, and those recordings will also be available to you in your InSkill portal. The course materials will be uploaded in your InSkill portal. So you'll be getting the login credentials for your InSkill portal. So for your portal, for each individual, you will be having a separate portal in the InSkill. So there you will be having all the course materials. You'll be getting access to the course materials.
Hello. Yeah,
Yes, sir.
this is Vaibhav from VLSIGuru. Am I audible to everyone?
Yes.
Yes, sir, you're audible, sir.
Yes, you are audible, sir.
Okay. So Vidisha, I have provided you the complete overview of DFT and how the training will go. I basically look into the management about during the training, what are the activities will be involved and how the placements will go ahead, as well as what is the criteria for placements or the protocols that you need to follow. Okay. So uh, many of you might be having a questions about the year of pass out. So can we start with the questions? Anyone having any questions?
Anyone raising the question?
వింటున్నా వింటున్నా.
Yeah, Vivek, Karthik, Namita. Okay, so before this one, let me walk you through about how this DFT training will go ahead. Vidisha, can you make me a presenter?
Yes, sir.
This DFT training comes under front end and back end.
This DFT, some companies put it into into front end, even some companies put it into back end. Now, why did we put it into backend? Because in DFT, no much coding is involved. Hardly only very long basics is required. So, if you ask about us, we consider it as a part of backend because almost 70% companies hire the DFT engineers and put them into the backend. Whereas there are few companies who consider it as a front end also. So it depends on company to company. But 70%, sorry, the work profile that you will be doing in DFT will be of backend only.
Thank you.
So is my screen visible to everyone?
Yes, sir, it is visible.
Okay, fine. So basically, how the training will go is it is a DFT designed for testability. The course duration is 6 months. It involves 2 months of basics and 4 months of main training. In the basics, we will be starting from the scratch that includes AND gate, OR gate, once complement to complement, and slowly we will move to the advanced topics. Here we will be in the 2 months of basics. We will be doing the digital design, Linux scripting, Verilog basics. These are topics we will be covering. If I walk you through the syllabus, see, it's as basics will be a 6 weeks program where you will be going through digital design, Linux, TCL scripting, and Verilog basics that you will be learning in the DFT basic course. Okay, then we will start with the main training. So main training is majorly focused on the industry requirements. What industry requirement is? A candidate should have a hands-on expertise on the tool as well as he has done some projects. The projects that involves is here is ATPG, IJTAG, even we have MBASed. So if I go over here, we have a very well structured curriculum. It involves starting from the introduction of the DFT. If I maximize each and every, we will be having a scan insertion, scan operation, as well as every week we will be doing the advanced topics that is required by the industry. Okay. Now, for doing all this, like suppose I'm doing the DRCs, even I'm doing the scan insertion. Okay. For this, a tool is required. So the tools that we have over here is mental graphic descents, Synopsys DFT Advisor, and Tetramax. The access to these tools will be 24 by 7. So you will be provided with your login credentials and then you can access the tool 24 by 7 to do the practice. During the course, we will make sure that you will be getting a 124 by 7 tool access for hands-on practice. Now what happens is the schedule is divided in such a way that if you are a fresher and you can dedicate a full week for this training, then you can opt for a full week schedule, which is Monday to Saturday, 9:30 to 1:30. Whatever sessions we are doing, that recorded videos will be provided to you. If you are a working professional, you can opt for a weekend course where Saturday, Sunday there will be sessions which will be 9 to 1 theory and 2 to 6 lab. Now, in this case also the recorded videos will be provided. How the recorded videos provided, that I will just demonstrate you. See, once you enroll for the course, we will be providing you the login credentials of our InSkill portal. When you go to the InSkill portal, you can log in. As of now, I will enter mine. So suppose you are enrolling for DFT. So in DFT, see, whatever sessions we are doing, let's take an example of this demo session itself. This demo session is getting recorded in the background. So this, after the session is done, within 3 to 4 hours, we will be providing you the recorded videos. This unit 0, unit 1 are nothing but the sessions we are conducted. So coming to the schedule, suppose someone opt for weekly full week schedule or even weekend schedule, but he is not able to attend or he is not able to understand few topics during the session. That live session will be shared via recordings onto their portal. Each video will be available for 1 week, so that if they miss any topic, they can go through the recorded video. And now when you are going through the recorded video, there might be some queries that you get or problems you are facing. Even 24/7 you have the 2 lectures. Still, if you, while doing, if you stuck any point, there will be a dedicated mentor provided for your doubt clarification. This is about the schedule as well as the during the course what we'll be doing. Now coming to the placement. So basically what is company looks into is the criteria and the expertise. So if I ask the questions to all of you, what is more important, criteria or expertise? Can anyone answer? Chaidatta, Namita, for a company to hire a candidate, what is more important? Is it a criteria or the expertise?
Expertise.
Okay, this is about Namita. What about that? What about others?
Expertise.
Okay, expertise. Yeah. So now 100% expertise matters. To give a realistic example, we have a company Wipro visited us last week. In that context, what happened is they were requiring candidates on an immediate basis to work on the project. So I asked them about what are the terms and conditions and the criteria. They said that they are okay with the criteria. Any year of pass out is fine, but it should not be around 2013 or 2012. So even if there are openings coming, but you are having a pass out year of 15 or 14, still there are chances for you to get into the industry. How? Suppose any X company comes to me asking for candidates, and if you are a good candidate, but if you are not as per the criteria, we can do the referral or even we can do the recommendation. Because what company is doing is, when we do recommend, they understand the candidate is good and he has the expertise. So they, if he has expertise, they are ready to uh, neglect the criteria and hire. But for that purpose, expertise is required. So one of the question was, what if I have multiple years of gap or 4 or 5 years of gap, 4 or 5 years of gap, still there are chances of you to get into the industry. Now, till this point, is everything clear?
Yes.
Okay.
Yes.
Now, when it comes to, I have just given a one example, but as we are keep updating the course content as well as the syllabus as per the industry requirements, we have tied with almost more than 70 plus companies. That includes Intel, Samsung, Microchip, UST, Cadence, Global Foundries, Synopsys. We can provide you the placements till you placement opportunities till you get a job. Okay. Yeah, but what is the criteria? Now coming again to the major criteria. that which even if you have 2 or 3 years gap or even 5 years gap, or someone who is a fresher now want to go into DFT, the criteria for all of you is same. What is the criteria is, we have the assignments, DFT assignments, even DFT questions, project assignments, everything we have. Your requirement is to complete at least 70% of these assignments. Now, these assignments are nothing like someone sitting and just making questions. These assignments are nothing but the question asked in the interview or the questions asked by the technical managers in the company. That's why eh, for you to get the placement assistance, 70% of the assignment should be completed. Minimum 70%. Now, why this assignment is mandatory? It is because, see, even if it's a service-based company or a product-based company, mostly there are 4 rounds of interview. That is, first one is the base written test, second is the HR round, third one is the technical discussion, and fourth is the salary discussion. Okay, your agenda should be to clear the initial 3 rounds. So even in the 2 months of basics, there will be basic assignments, as well as when it comes to advanced, each module will have the assignments. Why these assignments are? If in the basics of 2 months basics, we will make sure that you are at least qualified to clear the written test. So if you do the all assignments in the basics, it is 100% sure that you will be able to clear the written test. Now during the training, HR, sorry, in the interview there is a HR round. So for that HR round, we conduct multiple group discussions as well as multiple presentations and mock interview. These group discussions and the presentations will help you to improve your communication, so that at the end of, sorry, at the time of HR interview, you won't be facing any issues. And mock interviews are conducted by the industry professionals in such a way that when you go for a technical discussion, that is the third round, in the technical discussion they won't ask anything new related to the basics. They will just ask what projects you have worked, what problems you have faced, and they will put some scenarios in front of you, and they will ask you to debug them. So for that purpose, we conduct multiple mock interviews. Yeah. This is about during the course as well as after the course, what will be the placement criteria and how we can support. Also, we have explained the schedule about full week and this one. So now that's all from my end. Uh, Please let me know if you have any queries. Yeah. Karthik, Disha, Vivek.
No, sir.
Okay, Monica.
Sir, do we get any hardware materials, course studies
Sorry.
or course material?
Yeah, we
Sir,
will
do
be
we get
sharing
any
you.
hard copy?
Yes, we will be sharing you the hard copies of the course material also. As soon as the module is completed, we will be sharing each module hard copies.
Okay, sir.
Any more queries?
No, sir.
Oh, okay. So I had shared my number in the chat box, so that not only in this session, apart from this session, if you have any queries regarding the course, curriculum, or even during the training schedule, after the training regarding the placements, you can even get back to me on this number. Okay, we will be responding. Basically, we are starting a batch from this Wednesday, that is around 14th. So anyone have any queries or want to discuss anything before enrollment or want to confirm enrollment, please contact me on the number I have provided. We will provide you all the details.
Okay, sir.
Sure. Yeah. So any queries? Okay. So Vidisha, thank you so much for giving us the overview of the DFT. And
Thank you, sir.
thank you all for attending the session. I will be ending the session over here. Thank you.
Thank you all.